Hey everyone, it's Kenny. We are going to be building a powerful customer service AI agent from scratch in Python. If you've never built an AI agent before, then this is a perfect place to start. If you have built AI agents before, especially with frameworks like LangGraph, Pydantic, or Crew AI, you might sometimes get lost with the different abstractions in these frameworks or just the learning curves of these huge libraries. I promise you that learning how to build AI agents from scratch directly with the APIs is well worth it. Understanding the core design patterns in this video will not only set you up for success in building your AI agents and applications, but it's definitely going to accelerate your AI journey. You'll be able to effectively build more complex AI systems and understand why certain abstractions are important, better understand the design decisions that these different frameworks make and their trade-offs. So if you're ready to level up, let's get into it. This is going to be a beginner-friendly tutorial where I'm only assuming that you know some Python and you're maybe new to agents. But if you do have more experience with agents, then definitely follow along. I'm sure there's still a lot that you might learn here. But we're going to build up step by step by making our first API call to the OpenAI API and getting an LLM response, and then building on top of that where we're going to add tool calling, retrieval, memory, and eventually we'll build up to having our full customer service AI agent. All right, jumping right into the project. If you want to follow along, the code is in the AI Launchpad repo, which will be linked in the description. I just released this repo with the last video that we did, and going forward, this is going to have all of the projects, tutorials, code examples, etc. that I cover on my channel. So be sure to go give that a follow, save it, give it a star if you find it useful. And yeah, this will contain all of the projects going forward. You just have to set it up once, and then you'll be able to pull in the new tutorials and code that we release with each video. The README is going to have the instructions on setting up the project. Super simple. It's only like 4 steps, and then you'll have access to all of the tutorials in here. So we're going to start by installing UV if you don't already have it. I'm going to skip that step since I do have it, but I recommend managing your Python projects with UV because it's super simple and fast. And then the first thing we're going to do is go ahead and git clone the project to our local folder. So just navigate to where you want to install this, and then you can copy and paste the command there. That's also going to cd into the project folder once it's cloned. So now that that's done, you can just open up a code editor. I'm going to be using VS Code, so I'll just open this up, and then you're going to open a terminal in the project and run the command uv sync. And what this is going to do is it's going to create a virtual environment within your project folder. So you can see it right here, .venv. And this is going to install all of the dependencies which are defined here in the pyproject.toml. And if you see this pop up in VS Code or Cursor or whatever you use, make sure to hit yes. This is just asking if you want to use this new environment that we just created as the default for this workspace. And that might require you to restart your terminal. So you can just close the old one and then start a new one, and then it will go ahead and activate that new environment that we just created. If we head back over to the getting started instructions, the next step is just to add our secrets to the .env file. And for this project, which is going to be in the agents module, we're only going to need 2. One is the OpenAI API key, and another one is Tavily, and that is for web search. So we're going to give our agent the ability to search the web. Getting a Tavily account is completely free, no credit card required, so feel free to set one up if you do want to follow along. I'm just going to hop back over and copy this .env example, paste it, and then rename it just to get rid of this copy example so it says .env. And then we're going to go ahead and just fill in these first 2 API keys. These are the only ones you need for this project. Now this .env file is in the root, so it has our API keys for the entire AI Launchpad repo. So some of the other projects will use some other keys, but again, for this one, you can just ignore those. We're just going to be using OpenAI and Tavily. All right, I just set my secrets, so that's it for the project setup. Once you have done that, then you can just start running code. So we're gonna hop over into the AI Launchpad folder, and we're gonna be working within the agents module today. This project is called Agent from Scratch. So if you open this up, you're gonna see 6 files. Anytime you see a Python file that has a number and then underscore and a name, that file is meant to be ran in interactive mode as opposed to just a Python script that you can just run from the terminal. So if you open this up, this is meant to be ran in interactive mode, which means you can highlight blocks of code and then just run them by hitting Shift Enter. And that's going to open up an interactive window on the side, which we'll see in a bit. But yeah, just know that if you ran this as a script, you'd just get a bunch of printouts in the terminal, which wouldn't make a ton of sense because it's meant to be ran in interactive mode. So we're going to go ahead and start with the first file here, which is LLMs. Basically, with LLMs, there's different ways that you could call the APIs, right? We could use a requests library or HTTPX, any library that would allow you to make an API call, right? But if there's an SDK, then it's always convenient to use. In this case, we're going to use the OpenAI SDK. And all that means is we're able to use functions and classes from this development kit that will take care of a lot of boilerplate code for us. So instead of writing like a JSON body for a API request, we can just do something like this where we instantiate the Python client for OpenAI. And this is going to take care of connecting to the API using our environment variable credentials like the API key, taking care of the headers, for example. So we can just do something like this where we say client.responses.create and we're able to get a response. So our SDKs are just really convenient ways to interact with APIs. For OpenAI, there was previously the completions API, but they've since released the responses API earlier this year. So you should try to use that since that's the new standard going forward. Let's look at a simple example of calling this API where we're just defining which model we want to use. And I've picked 4.1 mini because it's pretty capable and cheap. I'm just going to highlight this code from the import statements down to getting this response and go ahead and press Shift Enter to run that in interactive mode. And then just as you can highlight lines of code or blocks of code, you can also highlight specific objects or specific texts. So I can just highlight the response, for example, and then inspect that by hitting Shift Enter. So this is the really nice part about running in interactive mode is you can explore different components of the code. And here you can see the response that we get back is this response object. It's going to have different properties like the ID for the response, and then you're going to have the outputs for this response, which is going to be an output message. There's convenient ways, since this is a Python object that you're getting back, it has attributes that you can access like output text. So if we want to just look at what was the text response from the model, we can run this. And then you can see out of this big soup of characters, somewhere in there you have this response. So you can directly access it by using the output text attribute. So that's your first API call. Super simple and straightforward. Next, we want to add a system prompt, and this is going to allow you to tailor your agent or responses from an LLM to your use case. So in this case, it's just a toy example. We're saying your name is Aura, always respond like a pirate. And we specify that it's a system prompt by the role. And the second message that we're going to add to this input is a user message, which is just going to be the same message that we had up here. So you can see the input is a bit flexible here. You can either pass in a string like we did up here and then get a direct response to that, or we can pass in a list of dictionary objects, which is going to be our individual messages. So this is how you would handle a conversation history, right? We could add more messages here from the AI back and forth with the user, and that would be your conversation history that you're passing in each LLM response. So in this case, we're just using the same user message as we did up here. So we can go ahead and execute that with the system prompt this time, and then look at the output text. The LLM responds by following our system prompt. Next, we have structured outputs. We're not necessarily going to be working with structured outputs with our agent, but I just want to show you how this works with the OpenAI API. You'll have similar methods with other APIs, like if you're using Anthropic, to get structured outputs, which can be in the form of JSON objects, or in our case, we're going to be getting a Pydantic object back out. This is a really nice way to have validation and coerce your outputs from the LLM into being very specific data types, which just makes your AI applications way more reliable. You want to define your JSON schema for the LLM to return its data in. And in this case, we're doing it with a Pydantic object. We create a support ticket object, which has a subject, and that's a string type. And then we have the body of the ticket, which is also a string. And here with Pydantic, we're just using a typical field description to tell the LLM what these parameters are for. And then, of course, having a doc string here is helpful, which just gives the LLM even more context on the JSON schema that it's supposed to provide. To get the structured response, we're going to call, again, the responses API, but this time we're going to use the parse method, and we're going to pass in just one more input parameter, which is the text format. So let's run this and then take a look first at the response. So I'm just going to highlight the response object. And you can see this time the response object is a little different. It's a parsed response, and it's inherited the type support ticket. So you're going to have some slightly different attributes here. The way we can access the actual object that we wanted is with the output parsed attribute. So if we execute this line here, you can see we get back a support ticket object, and here you have your subject and body attributes. So you can do something like, if you were running this in code, you could save it like that, and then within your code, you can say, I have this ticket with subject, and you'll be able to access the subject there. So this is a really useful way if you need to parse out information, like in this case, you have an email that was sent in from a customer or a message that was sent in, and then you're able to generate a ticket with the LLM inputting the subject and the body for that support ticket, so you can automate it. Finally, the last thing that we'll cover with the API calls is streaming. This is super useful if you are going to be building agents that are customer facing or even for yourself, because you need that feedback to the user that something is actually happening. So no one likes to sit there for 30 seconds waiting for a response to show up all of a sudden. So to stream, we're going to again work with the responses API, and it's the same method here to create a response. We're just adding one more input parameter, which is stream equal to true. We're using the same input as before with our system prompt telling Aura to respond like a pirate, and then our user message being hello world. Go ahead and execute that. And what you get back here is this stream object. So this stream object is basically a generator. We get back SSE events from the OpenAI API, and we just need to iterate through each one of those SSE events, and we can inspect the raw events with this print statement here. And I've just added this line separator so you can clearly see when we're getting a new event. Each one of these events is going to have different information, different data. So if we look at the first one that was printed at the top here, we get a response created event. So we've essentially created or started our response. And then we get an in progress event, an output item added, a content part added to that item. And you'll see you'll start to get these text delta events, which is going to contain the actual text. Here you can see the first token in this delta variable is and then you have oi, so ahoy, and yeah, you're going to get a stream of all of this. So because these events that are returned to us are specific types or specific classes, you can actually filter on that. So here in this example, we're going to filter for just the text events by checking that the event is of a type called response text delta, since we saw that has the actual text. So we're going to execute the stream again and then iterate through these events by filtering them. So it's kind of quick, but you could see the characters did appear progressively. So this was streamed back. This is only an example where we're just parsing out the text delta events. Again, you can check out the API documentation, which I'll link in the description, and it's also in the README for this project, where they go into a lot more detail on what are all the event types that you can parse out. Next, we have tool calling. Tool calling with APIs has 5 basic steps. I've linked up here in the doc string the docs from OpenAI on tool calling, and I think this diagram is really helpful. This is the outline of the 5-step process. So basically, we're going to define within our application a tool definition, and we're going to pass our messages that we want to give the agent along with the tool definitions to the model through the API. So in this example, we're passing in a definition for a get weather, and we're asking the question, what's the weather in Paris? So the model is going to decide that it needs to use this tool to answer this question. And what it sends back is a tool call. And that's going to include the name of the tool that it wants to call along with the input arguments to the tool, which for this tool is just the location. And it's getting that from, again, the input message. When we get that back in our application, we then have to call this tool, which is just going to be a Python function, and pass in the input arguments here that we're getting back from the LLM tool call. And we're going to get back a response from executing that function. In this case, it's a JSON object that says temperature is equal to 14. When we get the tool response back, we're going to send it to the LLM again so that it understands what the results of the tool call were. It's going to see that the temperature returned from the tool call was 14. So now it has the context of the temperature in Paris because of this function call that it made, and it's able to give a final response that it's currently 14°C in Paris. When you work with APIs directly, these 5 steps are what you have to do every time you want to call a tool and execute a tool with a model. In frameworks like LangGraph and others, this is abstracted for you usually. So this will be reduced down to one method or one class that will take care of the tool calling for you. So this is where you get into understanding why sometimes it is nice to have abstractions and why those frameworks can be useful. Imagine as we go through the code, you'll see this process. It takes a lot of code to do this, right? And so if you could just boil this down, since it's pretty much boilerplate and you have to do this with every tool call, if you can simplify it and just have one class or method to take care of the tool calling and run this loop every time, then that would be pretty convenient. Let's hop back over to the code and check this out in action. So I'm going to execute our imports and go ahead and instantiate our OpenAI client. And I wanted to show you really quick that recently OpenAI has these built-in tools that you can just call through the API. So you don't have to define them yourselves. They take care of defining the tools for you, executing the tools, getting the response to the LLM, and then having the LLM just send back the final response to you. So this is, again, a way of abstracting that low-level code away from you, but this is directly through the API. You can check out the docs to see what other built-in tools they have. We're going to be using the web search. I just want to show you that this is an option if you don't want to implement the tools yourselves. To use a built-in tool, we're again going to use the create method. We're going to pass in our normal model and input. In this case, I'm just using a string. And we're going to specify a tools list, which is going to take a dictionary, and we're going to say the type of the tool is the web search preview tool. So this is basically the name of the tool. And we're going to ask what was one positive news story from today. So in order to get the latest news, it has to use web search. So when you pass in a list of tools to an LLM through the API, what's happening on the back end is all of the schema and the definitions of the tool, the doc string, the input arguments, all of that information is injected into the system prompt by OpenAI or the LLM providers so that it has the context of the tools available to it. That's how it's able to take the context of your question and then understand the tools that it has and then decide if it needs one of the tools to answer your question. So that's how it works under the hood. So we can go ahead and execute this and look at the output text. So we can see in the output text that we just have the final response. So we didn't have to go through those 5 steps, right? We just get back this final response. And with specifically this web search tool, they've designed it so that it always includes citations. So here you can see the source link from where it got this news story. You can also access it by parsing out this particular object here, which is the annotations. So if I just print this out, you can see this is a list, and then you have these annotation objects, which is going to give you more information on the sources. So that's all convenient and everything, but ultimately you're going to get the most control when you build your own custom tools. Let's cover that. OpenAI calls it function calling. So function calling is just the same thing as tool calling, where we're implementing our own custom functions. As we saw, there's a 5-step process. The first thing we're going to do is just define the Python function that's going to serve as our tool. So we're going to do the same thing. We're going to implement a web search tool using Tavily. So this is why we had to set up our Tavily API. The function is really simple. It just takes in a query string for what we want to search. We're going to instantiate a Tavily search object. This is going to return a maximum of 3 results, and then we're going to go ahead and invoke it with the query as the input and then return the response. So we can go ahead and execute this and test it out. We want to search for how to make a grilled cheese. And I just noticed this warning that we got about the Langsmith API key. You can ignore this because we're using Tavily search from the LangChain library. And I didn't realize that they have it set up for observability and tracing with Langsmith. So if you don't have an API key set, which I didn't set one, it's going to warn you. Don't worry about it. The search still works. So if we look below that, here you can see the JSON response. The query was how to make a grilled cheese. And here you have this results key, which is going to be a list of websites that were returned from this web search. This is the output that we get back that we're going to pass directly to the LLM. The next step is to actually define the tool schema. So up here, we defined the Python function that we're going to be executing locally. Here, we have to define in JSON format the tool schema, which is going to give the LLM the context of what this tool is, what it's for, what it does. So we have our name, our description, which we want to have a nice, clear description of what this tool is for. And then you're going to have the input parameters, which for this tool, we just have one, which is the query, and that's of type string. And then we have a short description here. And we're specifying that this input parameter is required. So the model has to provide a query in its response. The next step then is to invoke the model with the tools that we just defined. So as before, we can pass in a list of messages, which can serve as our conversation history. Here I have a system prompt that says your name is Aura, you're a researcher, and you have a web search tool. And I'm telling it, don't rely on your own knowledge. Always use the search tool to answer the user's questions. So I'm provoking it to use the tool so that I can show you. And then we're asking what is the latest news about AI. So that's going to be our input to the model. And then you can see we're passing in that tools list that we defined up here with our tool schema. So if you had multiple tools, you would just add them into this list and pass it directly in like this. So we'll go ahead and execute that. Oh, we didn't execute this up here first. So we'll do that again and then print the output. So now we can see that in the output of our response, this time we have this function tool call object, right? So it's not just an output text. It's this new function tool call object, and it has for its arguments the input parameter to our function, which is the query parameter. It wants to call this tool and use for the query latest news about AI. So you can see here the name of the tool, and then each tool is going to have an ID tied to it. So what we do next is we can go ahead and add this function call to our conversation history. So we're going to append it to the messages list. And then we need to parse out the arguments for the tool. So we can go ahead and iterate through the response output, which is this list that you see here. We only have one object here, but you can actually have what's called parallel tool calling, where a model can call multiple tools in a single response. There are ways to disable that if you don't want it to do that, but I believe by default, maybe dependent on the model that you're using, parallel tool calling could be enabled. And so the way you actually want to pull out the tool calls is by iterating through all of the items in this response output list. So that's what we're doing here. And then we're just going to pull out the function call arguments and load them as a dictionary in Python so that we can later execute the tool. So once we have the function call arguments, which again is going to be a dictionary, we're just using JSON loads to load that into an actual dictionary. What we can do is then call the search web function, which we defined above, and we're unpacking those function call arguments to pass into it. In this case, it's just the query, right? But if you had more parameters, this is a convenient way by unpacking all of them at once and then just passing them into this function. We're going to save this result as this dictionary with search results as the key, and then the value is going to be the output from this web search tool. So I'm going to go ahead and execute all of this down to here. So now we can look at the result from our current tool call. And if we scroll all the way up, you can see here's our search results key, and then this is the output returned from the tool, which was just like we saw before. It has the query at the top, which this time is what the LLM is asking for. So latest news about AI, and then you have the results list below that. So now what we want to do is we want to add this function call output. So this is the result of running our function or our tool, and we want to add that to the list of messages. So we can just append a new message which has a type function call output. You have to follow this specific naming convention because it's how OpenAI parses the messages to look that this tool call was in fact called and there was a response returned. So we also need to pass in the call ID, which you saw in the function call up here. That's just going to be this ID up here. And that's again because we can have these parallel tool calls. You might have multiple function calls here. So you want to track what tool response belongs to which tool call. We'll go ahead and add the tool response. Now we can go ahead and print all of the messages. So this is just before sending the tool output back to the LLM so that it can decide how it wants to respond for its final output. If we look through here, we had our system prompt. We had the user asking what is the latest news about AI. We had our function call. Here is our latest message, which is the function call output with the proper ID following the tool call, and the results here. So now this is all of the context that the LLM is going to have on this next API call. We'll go ahead and call the API again and then look at the output text, and you get a summary on the latest news about AI. So this is the final response from the LLM. Finally, all we have to do is to append that final message to our message history, and now we can see the full conversation history, which basically is just adding the final response at the end of the messages. So that's tool calling. And if you've worked with frameworks before, again, a lot of this might be abstracted where you don't really see this loop and this whole mechanism of going back and forth with the API. But hopefully this is insightful in showing you what is the actual context that the LLM or your agents have when you are tool calling, whether it's in Python directly with the APIs or with frameworks. Next up, we have retrieval, which is just the process of getting additional context to incorporate into an LLM response or an AI agent conversation. And there are a ton of ways to implement retrieval. We're going to be covering probably the most powerful and common method, which is just using a vector database for RAG. If you're not super familiar with vector databases, they're just a type of database that allows you to store text data as vectors or a list of numbers. And having this numerical representation of different pieces of text allows you to perform really quick calculations to determine how similar those texts are to each other. So how related are they semantically? A popular open source library for doing this is ChromaDB. So we're going to be using that today to generate our vector database or our knowledge base. We'll go ahead and execute the setup code again. We're going to start by defining our Chroma client. And then we can call this method on the client get or create collection. So this is going to create a new collection in the database, which a collection is just a way of grouping all of the vectors that we want to search over. So for this example, it's going to be a catalog of products. So I'll go ahead and call that one products. Then you can use this upsert method on the collection that we just instantiated, passing in a list of documents. And what this is going to do is upsert each one of these documents and also take care of the embedding of these pieces of text to generate their embedding vectors and store those as well with each document. So we can go ahead and upsert that. And with this, we also need to pass in a list of IDs for each of those documents to index over. Once we have the collection set up, we can just immediately start querying it by using the query method, and you can pass in multiple questions or multiple pieces of text that you want the semantic search to happen over. So if it's just one user query or one question, you can just pass in a list with that one string. And then you can also pass in the number of results that you want returned back from this search. In my case, I'm just saying one because I want the one most relevant product to my query. So I'm saying I just started running and I'm looking for some shorts. So if we run that and look at the results, we'll see the most related item in our product catalog was ID 1. Here you have the document. So it's the Swift Stride running shorts, engineered for peak performance, blah, blah, blah. If we go back up, we can look at the other two items that were in here. You have yoga mat and a training hoodie. So clearly out of these three, this is definitely the most similar to our query. Now that we can see the querying works, we can create a tool around this. So we're going to define a search products tool, and we're going to pass in the query and the number of results that we want returned back. And I'll just quickly say, when it comes to tools and LLMs, typically you want to constrain LLMs or agents as much as possible. So in this example, we don't necessarily need to use this num results parameter. We can just define it in our code down here and remove it as an input parameter up here. And for example, just hard code this as 3. And the reason why that's helpful a lot of the times is you don't want to give your models a chance to make a mistake, right? And so the more simplified and constrained the task is for the LLM, in this case, it just has to provide one input parameter, which is the query. Usually the better reliability you'll have in your LLM application. In this case, we are including this as an input parameter because let's say for a product search, if you have tons of relevant results and you were only to return 2, you're not providing the full context to the LLM to be able to make a good decision for your customer, right? There could be 10 or 20 relevant products and you're only looking at 2 or 3 at a time. And so you don't have the full picture to be able to recommend the best product to your customer. So in this case, I'm giving it that control by using it as an input parameter. Just as before, we're going to define a tool schema for the OpenAI API. And what's a little bit different here is that now in the parameters, we just have 2 arguments instead of 1. But notice how in the required list, I'm only saying that the query is required. We have a default value up here of 3. So even if the model doesn't specify when we run this tool, this is already set to 3. And so even if we don't get back this num results, it's fine because it'll at least return 3 results. So I'm going to go ahead and execute the tool definition. For our messages, we're going to give a system prompt. Your name is Aura, you're a sales agent, you have a search product tool. Don't rely on your own knowledge. Once again, telling it to always use this search products tool. And we're passing in that same query. I just started running and I'm looking for some shorts. So we'll go ahead and execute that. So in the output, again, because we're leveraging tool calling for this retrieval, the response that we get back is a function tool call. At this point, you would have to go through that tool calling loop, which we just saw in the previous section. But this is basically what you would be passing to the LLM to then make a decision. And in this case, since we only have 3 products in our fake catalog, this tool response would have actually just given the entire catalog, which is the 3 items. And so the LLM would see that there's only 1 pair of running shorts and respond with this name of the Swift Stride running shorts. So retrieval is a huge field. There are a ton of ways to do retrieval and to optimize it. There's also retrieval that we typically do on the application side, where you're taking care of the retrieval and injecting that into the system prompt. In this case, I wanted to show you an example where the LLM or the agent has the ability to retrieve additional context and decide when and where it needs it. Next up, we have long-term memory. Long-term memory typically refers to context that we want to save across different conversations or sessions with an LLM or agent, as opposed to short-term memory, which is more of the context within a conversation or during that session. In our simple example, we're going to be using an in-memory store, which is basically just a Python dictionary. In reality or production, you would persist this to disk or a database like Postgres or MongoDB. But this is just going to be a simple example where we're going to save everything in memory, but showcase what that looks like for saving context across different conversations. I'll just quickly say also that we're going to be building this memory tool and giving it to an LLM. So again, letting it decide when it wants to create a memory to save this additional context for itself. In a lot of applications, you might actually want to manage this long-term memory yourself in the application, which again will provide some more reliability, or use a combination of both where you're allowing an agent to decide when it wants to remember something similar to like a scratch pad, and also manage additional context that you want to save in long-term memory, which you know will be important for your application. So jumping into it, we're going to create a empty dictionary, which is where we're going to be storing our memories. And we're going to leverage Pydantic again here to create some classes for saving our memories. So we have this memory class that's going to have an ID and the content of the memory. Then we have this function called manage memories, and this is kind of a 3-for-1 function where we're going to specify this input parameter action. The agent will decide whether it wants to create a memory, update an existing memory, or delete an existing memory. So you can see this is kind of a complicated tool for the agent to use. You really need to explain these different scenarios of, if it wants to create, then it should pass in an ID and content. If it wants to delete, it should just pass in ID. So we want to make sure we have good doc strings explaining what each of the parameters does. And then within the function, we're going to access that global memory store that we defined up here. And we're going to check whether the action was to create, update, or delete, and then do some validation just to make sure that, again, if we are updating, for example, we're passing in both an ID and content. So once we do that, we'll return all of the memories, so the active memory bank in the store. Then we're going to have another function which just returns all of the memories. So this is if the LLM or agent is working for some time and then just wants to check what memories it has. Maybe it wants to remember something. It can pull all of the memories. Obviously, a more sophisticated tool would be to be able to actually search memories, but that's, again, adding a lot more complexity. So let's see this in action. I'm going to go ahead and execute these function definitions. And then let's see an example of actually using this tool. So we want to create our first memory, give it an ID of 1, and say the user's name is Kenny. So if we do that, we get back the whole memories dictionary, which just has the 1 entry. We can update it and change the user's name to Bob, and then we can go ahead and delete that, and then now we have no memories. So that's how the tool works. And then we're going to go ahead and define the schema for these tools. So this time we're creating a list with 2 tools. We have our manage memories here with the 3 input parameters. And then we have another function for get memories, which takes in no input parameters. So we can pass in an empty dictionary. We'll go ahead and execute that. And then now coming into the input messages that we're going to pass into the LLM, you can see that we have a more extensive system message. Anytime you're working with tools, you typically want to be very descriptive in how the agent or LLM should access the tools, when it should access the tools, and any guidelines you have for how it should think about answering the user input. So we have this bigger system prompt where we're going into more detail on tool usage. I'm telling it here explicitly because I want it to actually use the tool. I'm saying, remember that my name is Kenny and my wife's name is Nancy. So let's go ahead and execute those messages and get a response from the LLM. So if we look at the output, we can see there was a function tool call. It's not just the LLM responding directly. And the tool call is to create a new memory. The user's name is Kenny and his wife's name is Nancy. So we can see this is exactly the output that we wanted. And again, we would go through the tool calling loop at this point to go ahead and execute that tool. Now for this example, I'm just going to go ahead and take care of creating those memories. I'm going to create 2, even though here the LLM wanted to create just 1 memory. I'm just going to go ahead and separate those out. Now if we look at memories, which is our store, we have those 2 memories, and you can imagine this being a persistent memory store. So let's say we saved this to JSON on disk, or again in a database or Redis. And let's say we start a new conversation. Now I want to get the LLM to use its get memories function and check what's in the store to see if it has information on the user that it can use to answer a new response. So this is again simulating a new conversation because we're starting a brand new messages list where we're asking, do you remember my wife's name? Right? So if we do this, and again, remember that it has no context within the actual messages that we're passing in, right? Nowhere here are we saying that who I am or my wife is. But if we look at the response output here, we can see that the LLM does in fact call get memories. And so if we were to execute this tool, it would see this set of memories in that memory store and be able to answer our question, even though within this conversation, it doesn't have that context. So that's long-term memory, super powerful and useful design pattern. Definitely something to explore for your agents. Lastly, before getting into the agent, we have short-term memory. And this is a much simpler form of memory. You can think of short-term memory as the working memory that an LLM or agent has within a single conversation. So typically that's just going to be the conversation history, right? The way we track that is super simple. We're just going to iterate or cycle through getting the user input, getting a response from the LLM, and each time we do that, we're going to add the user message as well as the LLM response to a running list of messages. And we're going to, every time we invoke or call the API to get a new response from the LLM, we're passing in that entire conversation history, so it has the context of what's been discussed so far. We're going to go ahead and start up a new conversation by creating this messages list with a system prompt. We don't have a user prompt in this case because we're going to collect it from a user input in a bit. But the system prompt is, your name is Aura, you're a great friend and love banter. Always keep the conversation going and lighthearted. In order to cycle between the user and the agent, we're going to use a while loop, and we're going to first collect the user input. The user is able to escape this loop if they want to by just typing in exit or quit. Otherwise, we're going to append that user input as a new message to the messages list. And then we're going to invoke the model with that full conversation history, add the response from the model to the messages list again, and then cycle back to the customer. So we're just going to be in this infinite loop. This is basically how you build a chatbot. So this isn't quite an agent yet because the agent doesn't have tools. It doesn't have agency or the ability to decide what it wants to do next. So this is really just a back and forth conversation, which is typically what you would see in chatbots. So let's see this in action. We'll go ahead and execute that whole loop. And we're immediately going to get the user input at this point. And I'll just say hi. And so our assistant says, hey there, what's up? Ready to chat or just dropping by? Just dropping by. How you doing? Ooh, I like surprise visits. I'm doing great. Just hanging out here in the digital realm. Blah, 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 blah. So that's how you have, so let's actually tell it a fact and then ask it a question. I like the color blue. So it acknowledges that I like the color blue. I'll say another fact about myself. I live in California. Totally irrelevant, just changing the conversation. And then now I'm going to say, tell me a joke. This model's so fast, by the way. This is 4.1 mini. Okay, and then so now we've gone back and forth a few times, and I'm going to ask it what color I like. And you can see it does remember that I like blue. So if I hit exit here, we exit that while loop. And what I can do is go ahead and inspect the messages list. And here you will see all of the back and forth that we just had with the model. And because we're passing in this entire message history again into each API call, it's going to have that full context, and thus why it's able to answer my question about what color I like. So short-term memory, super simple, but absolutely necessary for any AI agent. All right, finally, we have the AI agent. This is the main course, the peak of human civilization at this point. And what we're going to be building here is a customer service agent that can do a bunch of things. It can search a knowledge base, it can look up products, it can search an FAQ document to get answers to commonly asked questions. It's going to have long-term memory, tool usage, and really this is putting together everything that we've learned up to this point. So a lot of the code you've already seen, but I want to show you how we put it all together to create an agent. The one new thing that is really important to take away is the agent loop. So this is the core design pattern of agents. It's what makes agents agents and gives them the ability to decide what to do next, also known as agency. So we're going to see how you design that agent loop to allow the agent to perform a bunch of tasks, call all of the necessary tools, get whatever context it needs, do all of this work autonomously before coming back to the user to answer a question or to provide a result. So to start off, we're going to be defining the tools, some tools that we want to give our agent. Here we're going to create a web search tool, and actually this is literally just copying and pasting the same code as before. So we're going to create a web search tool. We're also going to be leveraging the long-term memory that we created with the in-memory store. And so we'll go ahead and execute that as well. This is, again, all of the same tools that we defined in the previous files. And for retrieval, we're going to set up a knowledge base where we're going to have different types of documents. So it's a little bit different than the retrieval file that we just went through earlier. Here in the agent from scratch directory, you can see a directory called knowledge base, and there's two JSON files here. So if we click into this, this is a list of JSON documents representing different products. So the name of the product, the price, the colors it comes with, etc. A description, which we're going to use for embedding and again being able to do a product search using semantic search. We're also going to include some metadata. I'm going to show you how you can do more complex search, not just similarity search, but you can actually pass metadata filtering. We can filter on things like category, whether it's for running or a different type of exercise, and also gender. So this product JSON is just going to have a list of a bunch of different products, and I literally just generated this with ChatGPT, so it's a great way to create some sample data when you're building your agents. We also have this FAQ JSON, and again, I just asked ChatGPT to generate this. So we have some questions. What is the return policy? Can I return a final sale item? Blah, blah, blah. So you have a few questions here along with the answers. And again, we have metadata specifying the category of that question. So it could be shipping related, related to discounts, etc. And you can imagine you can have a ton of different documents in here in your knowledge base. It could be related to your company. It could be related to other policies or specific products, etc. So feel free to drop in some additional documents if you want to there. But we'll go back to the agent file. And essentially that knowledge base directory is what we're using to create our knowledge base this time. So again, we're going to create our Chroma client. And this time we're going to iterate through each JSON file in this knowledge base directory. So we're just iterating through each one of those JSON files, getting the collection name, parsing that out from the name of the file, and then creating a collection. So in this case, we're just going to have two, which is the product and the FAQ. So we're going to have two collections. We're going to load the data from each one of those JSON files and then go ahead and upsert them item by item. So we'll go ahead and execute this. And now we can test it out by specifically calling on one of the collections. Here we're just going to use products and then running a query. Same thing as before. I just started running and I'm looking for some shorts. Now here's where you can do more complex queries by passing in the where parameter. And this has its own syntax. So if you want to filter on multiple metadata filters like gender and category, then you have to pass in a dictionary just like this with the and operator and then the two items that you want to filter on. by specifying the key and value for those items that you want to filter on. And then again, returning 3 results. So if we run this and then inspect the documents that were returned, we can iterate through each one of them and print them separately. We can see the first one is Ultra Flex running shorts. The second one is Speed Strike running tights. And then finally, we have running shoes. After we've created the collections, we can create our search functions for the knowledge base. So we're going to have 2 separate functions. One is to search products and one is to search the FAQ. The reason why we want to separate them is because the input parameters are going to be different, right? So the metadata that we want to filter on is slightly different. And so just to simplify things, we're going to separate them out. So you have search products where we're going to have our query, the gender if we want to filter on that, as well as the category if we want to filter on that. By default, they're none. So if nothing is passed in, then we won't actually apply those metadata filters. For the FAQ search tool, it's going to be a little simpler. We have, again, our query, and this time we're just going to have one metadata filter, which is for the category. So we can filter on whether we want to look at returns, shipping, discounts, or products. We're defining the JSON tool schemas down here. So I'm going to go ahead and execute all of this. And finally, we're at the agent loop. So this is a really important piece to understand. What we want to do is, for this conversation, we're going to create a empty memories store. So we're just going to generate a new one, and we're going to populate it with one memory, which is that the user's name is Kenny. So right off the bat, getting into this would be like, for example, if we had some stored information on the user and the user just started a new conversation, it would have this memory already stored that the user's name is Kenny. So we can go ahead and execute that. And that's going to be the starting context that we have. Next, we have the system prompt. This system prompt, you can read through it. It's a lot more detailed. And this is typically how you want to structure your system prompts for agents. You want to be really specific on what the agent's role is, what their goal is. You want to be specific on tool calling, when it should call tools, describing the tools that it has access to, when not to call tools, for example. And whenever possible, you want to go into more detail than you do in your tool descriptions, for example, in the doc strings, on when and when not to use tools, like what types of scenarios. And it's always helpful to give examples here. But again, the more thought out this is, usually the better your agent will perform. Oftentimes, having a few good examples will do a lot more for your agent's performance than just having a really long description. And that's because, kind of like humans, like agents can understand all of the nuances behind the examples. So if it sees exactly, this is a good output, this is a bad output, this is when you should use it, this is when you should not use it, it'll understand much more quickly and better when it should use certain tools. We're also telling it how to communicate, and then we're going to pass in the JSON schema for our tools, and then give it the context of the current memories. So here it's only going to see that initial memory that we created. So that's the system prompt. I'll go ahead and execute this list of messages here. And then there's a few things that I want to cover right before the while loop. Now, we saw the while loop in the last file. Here, there's a few more parameters we're going to set up before getting into the while loop. The first is route to agent. So this is a Boolean. Initially, it's equal to false. We're going to use this as a way to bypass getting the user input and just simply going back to the agent. So an example of when we want to do this is, let's say an agent calls a tool. We don't want to go back to get the user input, right? In the previous while loop, we were constantly going between getting the user input, getting a response from the LLM, and then going back to get another user input and then getting another response from the LLM. So that was like that chatbot design pattern. Here, when an agent calls a tool, we want to route back to the agent without going to the user, so that the agent can review the output of the tool and decide, do I want to call another tool, or do I want to maybe store a memory or draft my final response, right? So we want the agent to be able to decide when it actually wants to go back to the user. And so that's what this Boolean flag is used for. So if this is set to true, and we'll see the logic for it in the agent loop in a bit, but if it's set to true, then we will route to the agent and just bypass getting user input. So again, that's going to give the agent agency. We're also going to define a recursion limit because we are using essentially an infinite while loop here. You want to have some kind of escape mechanism, right? You don't want this to run forever. So here we're setting a limit of 30, and we're going to be checking that on each turn of this loop. And so we're keeping track of that with this turn parameter here. So if turn is greater than or equal to the recursion limit, we're just going to break out of the while loop. So that's one additional new thing that we have. Now let's take a look at how this loop is slightly different. So here, before we get the user input, we have this new check on this route to agent flag. So if not true, so if this is set to false, then we'll collect the user input. Like we said, if we flip this to true, then we want to route directly to the agent. We'll simply just skip this whole block of code and not get any user input at all on this turn. After that is when we actually call the response API, and we have our client with the model that we want to use, our input messages, same as before, and the tools that we defined above. And just like we saw with the tool calling, we're going to iterate through all of the items in the response output and check for those function tool calls. We're going to parse those arguments out, and for each function that is called, we're going to go ahead and call it. Here we're using globals, which is going to have all of the tools that we defined above. And we're going to go ahead and execute it by passing in the function call arguments for each tool call. So we'll go ahead and print out the tool call as well as the response from calling the tool up here on each turn. And then we'll append the function call output for each of those tools to the messages history. Now, this is where we are going to set route to agent true. So anytime a tool is called, we're going to flip this to true, and that will go directly back to the agent as we saw before. If there are no tool calls and there is an output message, so that would be the final output of the LLM response, then we know that it's the final response, and we'll simply add the message to the message history and then set route to agent false. So at that point, we can go back to the user because we've received the final response. So hopefully all of this makes sense and you understand how we're giving the agent through this loop and skipping the user input that ability to decide what it wants to do next before generating its final response and then going back to the user. So let's see this in action. I'm going to go ahead and execute all of the code up to this part here. And we're going to start by saying I'm looking for a pair of running shorts, just like before. You can see that the agent responds to me and mentions my name, so it's a more personalized response, right? And it only has that because we gave it the memory. So again, this is like long-term persistence. It's stored somewhere. It's able to get that context because we're injecting it into the system prompt. But this is a totally new conversation that we just started. So that's that long-term memory that you're seeing there. It's asking me about my preferences. I'm going to say I like black and I'm a size M. I'm going to Taiwan this summer, so I'm looking for a pair of running shorts because I want to run every morning. How's the weather in Taiwan in the summer? Okay, now we see a whole bunch of tokens being streamed. Let's scroll up and look through this output. Okay, so here was my last message. The first tool call that was called was to create a memory. The agent has decided that it wants to remember that Kenny likes black running shorts. And so we get the tool response that that memory was created. And then we get another tool call where the agent wants to remember that Kenny wears a size medium. So it generated two memories here back to back. And then we get our tool response. And this more than likely was a parallel tool call. And so you can see how our loop was able to iterate through each of the tool calls in that list of outputs and then generate the appropriate responses for them. So once we have that, we again get that Linksmith API key. You can ignore that. And that's happening because we are calling the search web tool just like we saw before. And the agent is searching for the weather in Taiwan in the summer. So this is all in a single user input, right? So the agent is going off and doing all of this work. And it's because of that flag that we set here, the route to agent flag, that it's just going back and giving all of these tool responses to the agent. And then the agent's deciding like what it wants to do next. So then we get the tool response for the web search query. We have another tool call where it wants to search the products now for running shorts, black, size M, and it's able to filter down the category to, the gender to men, and then the category to running. So that's pretty cool. It's able to distill down the products to exactly what it needs for this problem. And then you can see our tool response here. Finally, now it has all the information. It's able to generate that final response, which is that the temperature is around 27°C. For running shorts in black, size M, probably these are the best fit. And remember, the results that were returned for the product search, since it is passing in num_results3, it is getting back the other two products, like this set of running tights, which aren't running shorts, right? So like these are not as relevant product results since our dummy set has so few products, but it's able obviously to understand that this is really the only relevant product. And so that's the one it's going to suggest to us. So you can see how powerful this is. This agent has, maybe like 4 or 5 tools, but the tools span a lot of functions, right? You have retrieval, you have memory tools, you have web search. And so it's able to go off and do all of this work and gather all of the context it needs before coming back and giving you a really good response to the user. I can also ask it, since we haven't done anything with the FAQ, I can say, great, what's your return policy? And then it should use the FAQ search tool, which it does. And then it's going to look up the specific category for returns and then get the correct information here. So you can see the answer is a 30-day return policy. So it gets that right. And then it has this additional information. There's a $5.99 return shipping fee for refunds. So if we scroll up here, we can see that that is in the FAQ. So now you have these responses that are completely grounded in the knowledge we gave it. It's not going to be making stuff up and hallucinating. So that's Liv, our customer service agent. And I highly recommend you spend some time really understanding how this agent loop works, since it's a core design pattern that you're going to use for all of your agents. If you're getting into frameworks, a lot of this will be abstracted for you, but I think if you have this low-level foundational understanding, it'll really help you go a long way when you're debugging something or optimizing something that you've built with these frameworks. Lastly, I'll quickly mention that if you are using the OpenAI API, then you're going to have access to logging. So if you head over to platform.openai.com, you can go to your dashboard. And then on the left menu under Manage, you can click on Logs. And then just make sure that you're clicking on the Responses tab. This is the old Completions API. But if you look at the responses log, you'll see all of your API requests here, which is super useful if you're ever trying to understand what happened during a conversation, what did the agent see. So you can load the previous responses here, and this is going to have our entire conversation history in this trace. You can see how many tokens we used. Here's our system prompt, which was really long. And then you have all of our back and forth here. You have that initial memory that the agent generated to remember that I like black running shorts, and the rest of the conversation history here. So again, super useful when you're building agents to be able to understand what's going on underneath the hood. If you've made it this far, congrats, you have mastered how to build AI agents from scratch in Python. Hopefully you have a solid understanding of the underlying mechanics of building AI agents, and this should give you a strong foundation for building much more complex AI systems going forward. Speaking of which, if you want to continue learning and understand what are all the best practices for building AI workflows and agents, then definitely check out my next video where we implement Anthropic's golden guide on how to build effective AI agents using LangGraph. Thank you guys so much for watching. I appreciate every one of you. I hope you learned something in this video, and definitely leave me a comment down below if you have any questions or feedback. I respond to all of them. But yeah, thanks so much for watching, and I'll see you in the next one.